Topic 4, dynamics. Dynamics is really looking at forces and I suppose you could say the interrelationship between forces and the motion that is produced, whereas topic 3, kinematics, was looking purely at the motion without reference to any forces that cause that motion. All right, so a few basic things first of all to do with mass. All right, mass is a property of a body, and we'd find the rest of that statement in our learning outcomes. Probably, let's have a look, about almost halfway down, which resists change in motion. So take note, we're not saying that mass is the amount of matter in a body or something like that. We're talking about mass in terms of how mass um, is affected by a force. Okay, you apply a force, and the amount of mass that an object has results in how easy or difficult it is to change that motion. Something that is sometimes called inertia, and we'll look at that a little bit more when we get to Newton's law, second law of motion. Right, weight then is defined again in your learning outcomes as the effect, or it's stated in your learning outcomes, not really defined, as being the effect of a gravitational field on a mass. And then your learning outcomes also talk about weight being equal to the product of the mass of a body and the acceleration of free fall. So we get W equals mg, the formula that we are familiar with. Weight is measured in newtons. G, force divided by mass. All right, so in our statement here, we're calling G the acceleration due to gravity. You could also call G the gravitational field strength. Instead of measuring it in meters per second squared, you could measure it in newtons per coulomb. So when we say that G is 9.81 meters per second squared, that's the acceleration produced by gravity at the Earth's surface, or we could say that G equals 9.81 newtons per kilogram. So what we're saying is each kilogram of mass experiences a 9.81 newton force acting on it. Right, force on a mass in a uniform gravitational field. All right, so first of all, how is a uniform gravitational field being represented? So we're talking about uniform. It means it is the same everywhere. So the means by which we will do that, if we just get rid of this little cover, is by a series of parallel, equally spaced field lines, right? So it can be represented by parallel, equally spaced field lines, as illustrated. All right. Now, if we place a mass in that gravitational field, let's put it there. Now, whether that mass is there or whether it's here or anywhere, because the field is uniform, a mass placed in this field will experience the same force everywhere in the field. Right, related to mass and gravity is something called the center of gravity of a body. In IG, those who've done IG, it would have been called center of mass. So the two terms refer to the same point on a body. All right, so for your definition of center of gravity, I want you to look up your dictionary. All right, look up center of gravity, and in your dictionary, there is a very good definition of center of gravity. And do take careful note of what it says. It's not simply where the force of gravity acts. There's a key word in there. I think it might be the word considered or taken to or something like that. All right, so just take mental note of that. What we've got over here on the right is just an imaginary body where you've got mass spread all over that body. And each one of those little bits of mass will experience a gravitational force. Now that becomes a pretty complex situation. If you add up all of the forces of gravity acting at all these points, it might add up to 5 newtons, let's say. But what we can do is we can instead imagine that there is a single point called the center of mass, or center of gravity, we're calling it, through which the whole of the 5 newtons can be taken to act. And that just makes the analysis of some types of problems a lot simpler. Just a brief few statements about friction. Friction, first of all, is the force which opposes motion. It acts when a body is both. Now, you tend to think of friction acting when a body is moving, but it also can act when a body is stationary. Think about a slope and a mass sitting on a slope, and it is friction that holds it there. The body is not moving, it's the force of friction that is holding it there, stopping the body from sliding down the slope. All right, and the magnitude of the force of friction depends upon both the nature of the surfaces how rough or smooth either of the two surfaces that are in contact would be, and on the surface area in contact. So think about pushing something across a nice smooth surface versus pushing it across a rough surface. Think about having a small surface area in contact or a large surface area in contact. It's going to affect the size of the force of friction that's acting. Related to friction was really friction sort of really part of this general thing called viscosity. Viscosity is the internal friction that you can get within what's called a fluid. Now, a fluid could be a gas like air, or it could be a liquid like water. So the word fluid refers to both of those things, caused by, so viscosity is caused by neighboring layers of fluid moving over each other at different speeds. It could, for example, be water in a pipe or water in a river. The water on the riverbed would be moving at a different speed to the water above it. The riverbed grabs a hold of the water and it causes it to have a different speed. So moving over each other, sorry. This whole area is quite a complex area of study. If anyone headed into engineering, there's a whole area of engineering called fluid dynamics, looking at what's going on in terms of fluids. All right, so what might affect the viscosity in a fluid? One of the factors that is going to affect the viscosity would be the temperature of the fluid. If you've got some honey and the honey's really stiff and very viscous, what do? You stick it in the microwave and heat it up, and as the temperature of the honey goes up, then the honey becomes more runny. We say that the honey is less viscous at a higher temperature. And viscous forces, then carrying on with the idea of viscosity, also called drag forces. So a classic example of a drag force or a viscous force would be air resistance, where there is drag caused by that, or it could be the force that applies when, say, an America's Cup yacht travels through the water. And so what are they trying to do now? They got them up on wings to try and reduce the surface area in contact with the water so that the yachts can travel faster. All right, so viscous forces, also called drag forces, are frictional forces experienced by an object as it moves through a fluid, so a yacht through water, or a golf ball through the air, something like that, or by a fluid as it moves over a surface, water running through a pipe or water passing across the surface of a riverbed or something like that. If we think of one example, drop a ball bearing into a container of oil. Um, the ball bearing will accelerate initially, but very quickly will reach what's called terminal velocity because the viscous forces oppose the motion, and effectively then you get the weight force acting downwards equal to the viscous forces upwards, and so the ball then falls at a constant velocity. So what are the factors that are going to determine the magnitude of this viscous type force? It's going to depend upon things like the shape of the object. This whole business to do with aerodynamics. An aerodynamic car will cut through the air a lot more efficiently than, say, a big truck or something like that. It's also going to depend upon the nature of the surface. I've already sort of mentioned that in terms of rough and smooth with friction. And it's going to depend upon the nature of the fluid. I would suggest that honey is more viscous than water. And so you're going to get greater viscous forces by trying to drop something through honey than by, say, trying to drop something through water, let's say. All right, so the nature of the fluid. And we've already noted that temperature is going to be one thing that affects the nature of the fluid.